In this video, we'll quickly go over the big ideas of this chapter. So the very first thing I wanted to do in this chapter was just introduce the idea of quadratic relations, and I tried to relate it as much as possible to what you did in grade 9, which is linear relations. So I tried to express it in terms of a table, graph, and an equation. So I said there are three different ways of expressing the equation of quadratic relation: standard form, vertex form, and factored form. The graph now looks like a parabola, and your table of values now has a constant second difference as opposed to a constant first difference. And we also talk about the properties of the graph: the x-intercepts, the y-intercept, direction of opening, location of vertex, axis symmetry, optimal value, all that stuff. So after you got pretty comfortable with the graph of the quadratic relation, which is a parabola, we were ready to transform it. So you transformed it, transformed the y equals x squared, the basic parabola. I first showed you an animation, and then you're able to see the transformations, but then I wanted to explain the transformations. So that was not a really big lesson, but it was a two-part lesson. I used the animation first just to show it to you, and there wasn't much explanation there, but then we were able to explain what you saw by analyzing the numbers or looking at the equation more in depth. Okay, so that was very important to understand what you saw. And after you're comfortable with that, so you can state the transformations, you can really visualize the transformation, you can, of course, which is the third thing, is graph, using the transformation to help you graph from vertex form. So when we're talking about graphing from vertex form, there are three different ways. I really like the mapping rule way because that's what you're going to use moving forward in grade 11. But saying that, when I do the homework questions, I use a step pattern. So the step pattern is really easy. Plot vertex, find the step pattern, bam, 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 and you got your 5 points. So your original step pattern is 1, 3, 5. And based on what your A value, you just multiply the original 1, 3, 5 by A to find your new step pattern. So for example, if A is 2, your new step pattern will be 2, 6, 10. And that makes sense because you vertically stretch by a factor of 2, so the steps are twice as large as before. Another way of graphing is just using a table, find the vertex, and then find 2 points to the left and find 2 points to the right. After you graph from vertex form, you can graph from factored form. How do you graph from factored form? We get the zeros, which corresponds to the x-intercepts. And once you have the x-intercepts, you can use the idea of symmetry to find the x corner of the vertex and then find the y corner of the vertex. So this lesson was really nice because we were able to see that factored form is also useful because the factored form gives us the zeros, which corresponds to the x-intercepts. Okay, question 5, we found the equation of a quadratic relation. So this is very similar to what you did in grade 9, just find the equation of a line. I give you information, you find the equation line. In grade 10, I give you information, you find the equation of the quadratic relation. Now, sometimes you find the equation in vertex form, sometimes you find the equation in factor form. Very rarely will you find it in standard form. That only happens if I give you 3 points. And that was in the homework, so just do the homework and you'll see one of those examples. But yeah, and once you're able to find the equation, you can answer some word problems as well. So this is a very nice way of putting everything together. And the last thing we did was zero negative exponents, which really doesn't fit in with the rest of the ideas, but it's in the textbook. That's the way they structure the chapter, so I just left it like that. So zero negative exponents, just understand that zero exponents really mean you have a perfect balance of factors between the numerator and denominator. That's how you get a zero exponent. Whereas a negative exponent really is an excess number of factors in the denominator, and that's why you have a negative exponent. Because, for example, right? You have an excess number of factors in the denominator. That's how you get a negative exponent. So this 4 to the power of negative 4 really means there are 4 extra factors of 4 in the denominator. So that's basically the whole chapter.